Well, hi everyone. It's time for another Teton Pass update. You may have heard that yesterday, June 28th, Wyoming DOT completed their bypass section and opened the road to traffic at noon. And I want to go over those details. I think Wyoming DOT has done a good job of explaining what they're doing. I think they've done an absolutely lousy job explaining why. And I know some of you have taken offense at me pointing out the technical shortcomings that I think are apparent in this situation from the time just before the catastrophic collapse occurred on June 8th throughout their rebuilding effort here to get this bypass open. I understand the urgent need to get this bypass open, but if you've seen any of my previous videos, I think there's a lot of important technical questions that haven't been answered. I've been posing these questions. Local journalists have been posing these questions. Jackson Town Councilor Jessica Chambers has also asked very good questions. She had an op-ed in local papers expressing her concern about the pace of this rebuild and whether it was taking place prior to adequate engineering assessment and design. Because if it isn't, there's a significant risk to the traveling public, and also it could be completely counterproductive aside from the safety aspect if something has to be rebuilt or the road has to be closed down again. So I'm going to go over where everything stands right now and also share with you my main concerns. Now, I mentioned the people who don't like me pointing these things out. There's been many people, and clearly many of you are engineers that have reached out to me, have agreed with the concerns that I have brought up. And namely, I never saw how they could have possibly had enough time to gather and analyze the requisite geotechnical data, the subsurface information about the foundation soils, about the embankment soils, and to do a proper design that would be reliable and safe. Even though they plan to only use this for a few months, it's still, a few months isn't exactly short term in geotechnical engineering in terms of soil strength and pore water pressures in the soil. So I'll go over all these details. And again, I can understand why some of you, if you're engineers and you're local, why you would be reluctant to voice your concerns publicly. There's a large contingent of what I call the get her done crowd that just wants to move earth and get the road reopened and not ask a lot of other questions. Now let's look at what this failure looked like initially. This is from Wyoming DOT's YouTube channel. You can see catastrophic failure took out the entire section of roadway shoulder to shoulder in this area of the slide. So they've gone from that to this in a 3-week span. The embankment that failed, I understand, is approximately 70 feet tall. It looked taller than that to me from the photos, but that's what's been quoted by Wyoming DOT officials. And the new fill section is approximately 40 feet high, although it looks a little taller, but let's just say it's 40 feet. A little bit shorter in height than the other section. Here we see the first vehicle going through the bypass section. Now on Thursday, June 27th, Wyoming DOT issued this press release indicating that they're planning to reopen the roadway on June 28th, which is what they in fact did. So there's a current 60,000 pound gross vehicle weight restriction, which apparently has been in place for a while, but no additional restrictions except for a 20-mile-an-hour speed limit through the bypass. Now this is the part that I want to talk about close to the bottom of the page here. Wyoming DOT's professional geologists have evaluated the stability of the detour roadway. Geotechnical analysis confirms that the temporary detour meets or exceeds minimum requirements as outlined in guidance from the Federal Highway Administration. The calculated factor of safety for the stability of the detour exceeds 1.2, with 1.1 being the minimum acceptable to WYDOT's professional licensed engineers. Well, in my opinion, those factors are way too low and are in fact not consistent with federal highway guidance. I'll show you the reference that I'm looking at. But also I think it's odd in their press release that they just say it's more than 1.2. Why not just say what the number was? So 1.1, 1.2, I think I know where they got those numbers, and I think those numbers are wholly inadequate. But again, it seems to me like they're just throwing numbers out there. It's odd that they don't say, well, this was our factor of safety for the critical shear surface through the embankment. Now, the other part of this press release, they mentioned some of the details associated with that detour roadway section. It's 600 feet long with a grade of 11.2% and a sharper curvature. So they're going to reduce the speed to 20 miles an hour through that area. And WYDOT has acknowledged that that grade and slope do not meet design requirements for roadways. So they plan to address that by rebuilding the roadway embankment at its original location to restore the area that had failed previously. WYDOT arranged for members of the press and other officials to travel to the bypass location, and they held a press conference. Most of the press conference was dedicated to the typical congratulations and acknowledgement of various government officials, although they did recognize the very good and hard work done by the contractor here. I mean, it is very impressive that they rebuilt this roadway section for the bypass in under 3 weeks. It involved over 30,000 cubic yards of material. Director Westby said 30,000 cubic feet at the press conference, but he clearly misspoke. It was 30,000 cubic yards. So that's a lot of material to place and compact and move up and ultimately pave within a 3-week window. Again, all my critiques have been really reserved for the decision makers here at WYDOT, and that's relative to the geotechnical aspects that are apparent. So after this press conference, there was a small group that broke away and asked several questions of James Dahill, Wyoming DOT's chief geologist. So this was just an extension of the press conference, and I'd like to thank town councilor Jessica Chambers. She sent me audio files that were recorded at this press conference, and including the Q&A that occurred with Mr. Dahill. So let's play this first audio clip from this Q&A session with Mr. Dahill. And keep in mind there's a bit of background noise, but I'm going to recap what he said after I play each audio segment.
So shortly here in July, we'll be meeting with contractors from around the globe, really around the whole western United States and everywhere, to brainstorm what to do with the clay option and what we can do to mitigate it so that we can design a roadway to a factor safety of 1.3.
So what he's referring to there is their efforts going forward here immediately to restore that roadway embankment section that had failed here 3 weeks ago to its previous grades and slopes. Okay, so he mentioned the clay, what to do about the clay. So that clay layer in the foundation soils, the natural material that was below the embankment fill that was placed in the 1960s, those old foundation soils became wet, apparently from rain and snowmelt from earlier this year, and became saturated, which increased the pore water pressures in the clay layer and caused a reduction in shear strength. A reduction in strength led to that catastrophic failure on June 7th/June 8th. Now, he mentioned at the end there, their goal is to have a 1.3 factor of safety for the rebuilt main embankment. And again, I think that's very low, but what I'm referring to here on a factor of safety is from a limit equilibrium analysis. And I've covered this before, but I think it's worth mentioning again. This is a way to model the stability of a slope. So you start out with a good cross section that represents the geometry accurately of the slope and also where the location is of the foundation soil layers. And then you select what's called a trial shear surface, representing a potential plane of failure if that material were to slide. And then you take that mass of material and you divide it into slices where you're calculating the weight of each of those slices. Those are the driving forces at the upper portion of the trial shear surface, and the self-weight of slices towards the bottom actually act to resist the driving forces. And the other thing resisting the sliding of this potential mass of material is the soil shear strength along that potential failure plane. And this is what you want to not have, is a rotational failure that takes out a large section of the embankment. And WYDOT's confirmed, and of course it's obvious now from the pictures, that that was a large rotational failure that went through the clay layers in the foundation soils below the embankment fill. Now let's look at Federal Highway guidance, because their press release mentioned that they're following FHWA. This document from May 2007. It's stamped draft. I couldn't see where they've issued a final version of this, but what they recommend in their guidance includes what you should do for a geotechnical investigation, the type of drilling, soil sampling, strength tests, and so on that you would do for an embankment slope like this. And they also cover what should be the typical factors of safety. So they talk about here in the third sentence, for slope stability analysis of significant fill slopes, the desired minimum factor of safety, FS, is typically in the order of 1.3 to 1.5, depending on the levels of importance and risk and the uncertainty in the slope analysis input parameters. So when you're less certain about the soil properties, or it's a really important embankment, which I think both of those conditions were met here, that they really didn't have enough time. I can see how they possibly had enough time to capture all the information and analyze it regarding the strength of the foundation soils and the embankment fill materials prior to starting the construction of the embankment for this bypass section that's now been open to traffic. So per the FHWA guides, you'd be looking at a factor of safety of 1.5. You know, if they had all the geotechnical information that they needed right now, they could have essentially designed the restoration of the main embankment instead of building this bypass section. Now let's talk about here. Factors of safety for short-term conditions, i.e. during construction, can be less than the long-term factors of safety, typically about 1.1 to 1.2. Well, this embankment isn't under construction anymore. It's been open to traffic. So WYDOT in their press release saying they're good with a 1.2 or 1.1 factor of safety, although they said they think it's higher than 1.2, but they don't say how they came to that conclusion. The fact is that they're throwing numbers around that are really low and not consistent with important structures and not consistent with an embankment roadway that's now been reopened to traffic. And that's my opinion. So I'd be curious if any of you engineers out there who are involved with roadway design and in particular geotechnical engineering, if you'd be comfortable having a 40-foot plus tall roadway embankment that's open to traffic with such a low factor of safety, you know, something significantly lower than 1.5. So let's just look at another reference outside of FHWA. This is a paper really contrasting two-dimensional slope stability analysis with three-dimensional slope stability analysis. You use 3D analysis when you want to more accurately model the effects of, say, reinforcement, such as geogrids and other stabilizing measures in a slope. It says, decades of research and inverse analysis of slope failures have resulted in widespread acceptance of certain factors of safety in typical situations. That is, a static two-dimensional factor of safety of 1.3 is often used for temporary or low-risk slopes and 1.5 for permanent slopes. So that's exactly what I've been saying. Now I'm going to put a link to this news article. This was written by Billy Arnold with Jackson Hole News and Guide. He was there at this on-site press conference, and he's summarizing Mr. Dayhill in terms of what he said at this press conference relative to what caused the failure. 4 factors cause a landslide: a substantial driving force on top of a slope, a lack of resisting force at the bottom of the slope, and a weak layer in or beneath the slope, and critically water. The part of the pass that failed on June 8th is known as the Big Fill, a 70-foot high embankment that highway engineers built in the 1960s to make the modern Teton Pass highway a manageable 10% grade for cars. But over the years, water got into the fill and for the last decade or two caused instability. Engineers put an inclinometer, a device that measures slope movement, in the hill last fall. The fill did not, however, move substantially until a few days before the collapse, officials say. Geologists blame a stout runoff season caused by a combination of hot days and warm nights that pushed groundwater through an underlying layer of natural clay. Now, this is a key part of this article. The clay also exists a few hundred feet south where the temporary bypass is being constructed. However, even with that layer present and without a full stability analysis, Dayhill, WYDOT's geologist, said a number of factors make the area under the bypass more stable than what failed under the Big Fill. Well, that may be true, but I don't understand how it's okay to not complete your analysis. I mean, Bob Hammond, the district engineer for WYDOT in charge of this project, said that on June 9th, the day after this failure had occurred, they completed their design. And I think in a subsequent quote, he extended it to a 2-day period. So over a period of 2 days, they decided where the bypass embankment was going to go, how tall it was going to be, and what the grades and slopes were going to be. Now, again, how could they possibly do that in such a short period of time in order to have the requisite geotechnical data at hand? I mean, by June 9th or 10th, they hadn't even completed any of the borings, to my knowledge, that they would need later for sampling and for installation of instrumentation. Now, they may have had some prior borings out there, but that clearly didn't help them too much in predicting the catastrophic failure. And the other thing that I've noticed from their statements is they said the last time that that inclinometer in the slope that failed had been read was in May, and it showed no signs of movement. But when they became alerted to additional movement on June 6th and June 7th that caused these cracks in the roadway pavement to open up, there's no indication or no statement on their part indicating that they did another reading of that inclinometer casing. So to me, that's a bit troubling. Now I want to go towards the bottom of this. The area where the bypass is being built also has not already experienced the same stress as the area under the big fill. Until 2 weeks ago, it was all native soil without a man-made load on top. So that's very concerning to me, because a key consideration for building embankments is to determine what the rate of fill placement should be so that you don't exceed the shear strength of the foundation soils and cause a failure. So Mr. Dayhill has acknowledged that water from rain and snow melt got into this clay layer in the foundation soils and increased the pore water pressure, which decreased the shear strength of the soil. Another way to decrease the shear strength is to rapidly load it so you build up pore water pressures. So the soil doesn't really distinguish between water that's come in from rain and snow melt that increases the elevation and the water pressures within that foundation soil, or increases in those water pressures because there's an overlying load that's suddenly being put into place. Now, in response to several technical questions posed by the media and others, the chief spokesperson has been Mr. Dayhill. So I want to play a couple more audio segments here.
Okay, so you'll figure that out before the spring.
Correct.
The new plans.
1.3, what you just said, the safety factor.
3 times the ground improvement.
What does that mean?
So we're going to improve it 3 times above normal. So
For the permanent.
normal would be 1, right? Normal would be 1, not failing. We're going to 1.3, so we'll go 3 times that. So 1 is equilibrium. If it's less than 1, it's not equal or it's not stable. If it's over 1, every 10th above that is a factor of 10 times improvement. So 1.1 is 10 times better than 1. Factor of 1.2 is 20 times better. So that's our.
Okay, the reason why I wanted to play that, and I actually debated whether to play it, it's so embarrassingly incorrect. And again, you know, Mr. Dayhill's probably sleep deprived and been extremely busy and got a lot going on. But again, he's been the key spokesperson for WYDOT on these technical matters. And what he just said is incorrect. A 1.3 factor of safety means there's 30% additional resisting forces relative to driving forces. It's not a factor of 3, and then he contradicts that later by saying, you know, every 0.1 increase in factor of safety is a 10-fold increase in resistance. That's obviously not true either. So clearly, WYDOT, I would hope actually, has somebody else involved with the details with the slope stability analysis. But again, Mr. Dayhill's the one that's been assuring everybody that, hey, this thing's safe. But is he just taking the word from other people and he's garbling the technical aspects of this? I mean, he's garbled it there. And again, the 1.3 factor of safety he's talking about is for the reconstructed portion of the embankment that they're planning to do before the middle of November this year. Now, Wyoming sent out a request for qualifications for interested parties who could come in and design and construct a restored section of the roadway embankment, basically to a pre-failure configuration. Said generically, you should look at lightweight fills. There's been instances where people use styrofoam in big blocks to replace soil materials, so it has a much lower density. dewatering and control of surface water, and ground improvement. Or it could be a combination of these techniques. It says the slope stabilization will occur prior to the permanent roadway being open to traffic. Two-way traffic will need to be maintained at all times during slope stabilization and roadway reconstruction. Well, that's going to be a pretty tough situation. If you look at this scarp, I mean, there's a near vertical scarp where the embankment failed, and it's in rather close proximity to the new roadway. I mean, let's look at this, and I'll highlight the top of the scarp here. But if each lane is 12 feet wide, so it's 24 feet, plus say a 7-foot shoulder, that's 38 feet roughly for the width of the paving here. It's about that same width or distance, as it were, to the edge of the scarp. I can tell you that looks to be primarily sandy material. A near vertical slope is not an equilibrium slope. It's a slope that would be expected to continue to ravel with shallow slides occurring and extending the edge of that scarp closer and closer to the roadway over time. So that's what they're referring to. They need to stabilize that, but I guess why didn't they stabilize it before they opened the road to traffic? As Mr. Dayhill indicated, on Wednesday, they were still out there drilling, sampling, and installing instrumentation to monitor this area. And as I've shown in other videos, they had an inclinometer. It's a pipe with slots in it where you can insert a probe and the wheels lock into those slots, and it has an accelerometer, so it's able to plot the orientation of that casing throughout its full length. And the idea is you install that casing through the embankment fill and well into the foundation soil, so you can pick up any location of movement that may be occurring. So this is a review of one of those probes. Typical inclinometer data output plots. Apparently there were no piezometers to measure pore water pressures, although I believe they've put them in now, or in the process of putting them in. Another segment of that article from Jackson Hole News and Guide. After questions from the News and Guide last week, WYDOT officials said Tuesday that they're investing in tech that will allow them to monitor the bypass 24/7. The department plans to install a $50,000 piece of technology called a constant array to take readings on groundwater and soil movement in real time. I think they later clarified that they've got one conventional inclinometer and then one with this automated instrumentation. They also plan to use the device to establish numerical thresholds for movement and water issues. If the bypass moves too much, WYDOT will get an alert and will conduct a thorough evaluation, Dayhill said. Whether the pass will remain open or closed in the event that threshold is met will be decided in the field. So let's go to the last couple of audio clips.
And then what about the soil samples and the compressibility and all those analyses? How's that moving forward?
Excellent.
Yeah.
We're testing it as we speak.
Yeah.
We have numbers. We're providing it to our design company that's on board with us, another expert, Landslide expert. He's helping us develop those models. And he has developed models. We're just going to back it up with the numbers so that we have the utmost confidence.
Okay, so again, he's referring to the analysis. As of Tuesday, they still hadn't announced what their factor of safety was for this bypass roadway that they were getting ready to reopen to traffic.
Will the bypass open before we have that confirmation that all of this thing is, lining up as far as like the analyses, the stability, the safety, and then the opening?
I think that is our intent, and I won't speak for the local boots on the ground guy here.
Yeah.
That's Bob behind you, John Evans behind you. But yes, that is the communication with our director. Let's get those numbers before we open. Safety is our number one base.
Okay, so you saw that, or heard rather, Mr. Dayhill saying that their intent was to have the overall stability computed for this bypass section of the roadway before they reopened it to traffic, but that wasn't going to be his call. It's like, are you serious? I mean, if you're the chief geologist, wouldn't you insist that that calculation had been performed and met requirements before you're going to let somebody else decide to reopen the roadway? So I think that just illustrates the political nature of this project, in that is pushing the reopening of this road so quickly prior, in my opinion, to having sufficient time to do a proper geotechnical engineering study and an analysis. So let's go back to the press release from WYDOT. So this is on June 27th, the day before they opened the bypass to traffic. WYDOT remains committed to monitoring the area with geologic infrastructure, including real-time information on subsurface movement and ground-based radar detection, along with personnel inspections. So again, they didn't categorically state that this system's up and running at the time they reopened the roadway. And there were earlier comments from WYDOT officials saying that they're going to have people out there inspecting the roadway, looking for cracks and other forms of distress, and monitoring this instrumentation. I mean, are they going to be out there at 3 o'clock in the morning if need be before this automated system is online? Again, if this system was online, why didn't they say so in the press release? So let's go back to this request for qualifications. These letters of interest, as it were due by June 28th, so yesterday. So presumably any interested parties turn those in. It says the contractor is expected to partially complete the construction, including a stabilized slope and a drivable surface by November 15th, 2024. Well, if you have a stabilized slope and a drivable surface, what would be left to complete for the construction? I'm kind of curious about that. Unless they're keeping the door open to maybe having a gravel section there if it's too late in the year to actually pave it with asphalt. So that timeline was confirmed by WYDOT Director Darren Westby, who indicated that the plan was to have this design with the start of construction going by August of this year, with the roadway completed by the middle of November this year. So if you look at it, obviously the main section of the embankment that had a prior failure is a bigger section than the roadway that's for the bypass right now, but not by much. So how is it possible to basically design that bypass that's probably at least 60 to 70% of what was required or would be required for the main roadway section, and design it in a day or two and build it in 3 weeks? But yet to restore the main roadway embankment is they're going to be hard pressed to get it done by November. So what is that? July, August, September, October, 4.5 months. And I'm not suggesting that they should complete it any sooner. I'm just illustrating here the apparent disconnect. It's like, how can you build substantially the same thing by designing it in a couple of days and building it in 3 weeks, but the permanent thing is going to take several months, which I think is going to take every bit of that? And the answer is it doesn't make sense. I don't see how they could possibly equate the logic there in terms of the analysis and design and planning for something like this. I'd like to send a shout out to the channel members. I really appreciate your ongoing support. I also like to thank those of you who've provided super thanks. That's another way to support the channel. I've got a new digital download. I'll put a link in the description, so please check that out. And while you're down there, please hit those like, subscribe, and notification buttons if you haven't done so already. I'll continue to follow this story as well as others. There's a lot of interesting things going on out there these days with infrastructure and buildings and things of that nature here in the U.S. So I also cover stories that are of international interest. So thanks very much, everyone.